Alright, and welcome to this video. I'm going over these challenge questions, and I really hope that you've tried them yourself first and see how well you did on it. The first question is about a train that travels for a while and then waits for a while and then travels for a while, and we need to find the total displacement, and we need to find the average velocity. And I also recommend in this question that we convert the units first. So let me do the convert the units first. I guess the real reason why we want to convert the units is because the question is done in kilometers and kilometers per hour and minutes, and then at the end we want the answer to be done in meters per second. So we got to make these things kind of all the same. So I'm going to show you, if I haven't shown you already, my general method to convert units. Then here I'll do it now, and then I'll probably erase the space. So you might want to do it on a different sheet of paper, because I'll use this white space afterwards. So let's look at this 58 kilometers, and we want to convert that so it has some number of meters. So what I'm going to do is multiply by a fraction that has the value of 1. So in other words, if the top of the fraction and the bottom of the fraction are equal, then I'm really only multiplying by something that is equal to 1. I want to get rid of these kilometer units, so I'm going to put kilometers down here, and I want to turn it into meters units, so I'm going to put meters up there. So now my task is, how do I make this equal to 1? A meter and a kilometer are not the same, but I could say that 1,000 meters is the same thing as 1 kilometer. Okay, so now see how easy this is. The kilometers are going to cancel each other out, and my answer is going to be, well, what's 58 times 1,000? The answer is 58,000 meters. Okay, so that's this one done. So this is going to be 58,000 meters. Now let's do a harder one. Let's do the 72 kilometers per hour. So we've got 72 kilometers per hour, and what I want to get it into is this unit here, this meters per second. So I'm going to say, alright, well, at the end of this I want it to be some number of meters per second. So that means, well, the first part's the same, isn't it? I need to do that kilometers into meters business. So I'm going to say 1,000 meters over 1 kilometer, and just yet again, this fraction, 1,000 meters and 1 kilometer, are the same, so I'm multiplying it by 1. Now this is a bit more tricky. Here I've got hours in the denominator, and I want to have the seconds in the denominator. So I want to have seconds down here, because that's what I want my answer to be, and want to get rid of hours, so I'll put hours up there. Now I have to think, okay, just like 1,000 meters was equal to 1 kilometer, what's the relationship between hours and seconds? Well, let's just think 1 hour is equal to 60 minutes, but each minute is equal to 60 seconds, so 1 hour is actually going to be 60 times 60. So it's going to be 1 hour, it will be 3,600 seconds. Okay, so now I've got these two fractions that are both equal to 1. So when I do my math, I can do 72 times 1,000 divided by 3,600. So then I get a nice cool number of 20. By the way, this conversion from kilometers per hour to meters per second you do fairly often, so this wouldn't be a bad one just to kind of remember. Well, multiplying by 1,000 and dividing by 3,600, you can also just think of this as dividing by 3.6. We'll do the same thing. So 72 divided by 3.6 is the same thing as 20 meters per second. So I'm going to go over here and I'm going to put 20 meters per second over there. 5 minutes isn't so hard. 5 minutes here is the same thing as, well, 5 min times 60 seconds for every 1 minute will be equal to 300 seconds. And similarly, 54 kilometers per hour, again I can just do my divide by 3.6 shortcut, and then I think I get 15 meters per second. Okay, so we've got a bunch of writing on here now. I'll just kind of neat this up a little bit. 300 seconds over there. Okay, so that's how you do the conversions. So if you're fine with that, now let's just go back and take a look at the question a little bit. I'm going to erase this stuff so I have a bit of room. So this is Well, you know what might be a nice one? Let's draw a position time graph of the whole thing and just take a look at it. So here's our position, here's our time. In the first segment, the part A, they go 58 kilometers at an average velocity of 72 kilometers per hour. And that's the fast, sorry, I should say 20 meters per second. So how about if I go like this and I'll say, okay, here's a steep section. Here's section A. Steep because they're going faster, they're going 20. And then they wait for 300 seconds. They wait for 5 minutes. So then that looks like horizontal. That would be section B. And then they go at 15 meters per second, so not as steep for a while. That's section C. And then the question is, what is the total displacement? So the total displacement, well, that would be this section here. From all the way from where we started here to all the way up here, that would be the total displacement. There we go. And the other question is, what's the average velocity? Well, the average velocity is going to be equal, remember our model, delta x over delta t. But the key is that this has to be the total. Maybe I'll put a t here for total. T here for total, and then the total time that goes by. So another way to show it is you could say, oh, it's the slope of this line, right? Where this one is, the slope is the total displacement divided by the total time. So why don't we think about the displacements first, and it'd be nice to, I think, organize this into our three sections. We can go A, B, C, and then here we can say total. And let's start off by thinking about the displacements. So in other words, let's see if we can figure out the displacement for A, for that first segment, the displacement for B, and the displacement for C, and then this one will be those ones all added together. Maybe I'll just say total, and we'll see that we're going to add them all up. Okay, so the first one says a train travels, well, there we are, 58,000 meters. Okay, so that one's done already. 58,000 meters. Train B, or part B, pardon me, well, it's not moving, it's waiting. So this will be 0 meters. And then part C, this is the one we have to work for a little bit. They tell us it runs for half of an hour, which is 300 seconds. Or wait, half of an hour, we didn't do that one. Okay, 300 seconds is to 5 minutes. So here, let's say half of an hour. So delta t in this section for part C equals half of an hour. Well, if a full hour was 3,600, this would be 1,800 seconds. Okay, and the other information that they give us is this velocity during period C was 15 meters per second. So what's the relationship between these three? Well, average velocity is equal to the displacement divided by the time. It's the same idea as looking at that slope. So we need to rearrange to solve for this displacement. So if we multiply both sides by time, and we plug in our numbers here, we got 15 times 1,800 equals a pretty big number. I think we'd have to get our calculator. 27,000. 27,000 meters. So here it is, 27,000 meters. So what is the total displacement? We can even kind of label this in here. This would be 58,000. And then between here and here, section C, is another, 27,000. So jump from here to here is 58,000. And then we would have to add the 27,000 to get the total. So what is that? 85,000 meters. Okay, so here we're half done already. So we got this part, find the total displacement. Now we want to find the average velocity for the whole trip. Now be careful. You don't want to just say, oh, this one was going at 72 kilometers per hour, this one was going at 0, and this one going at, this one was going at 20 meters per second, this one was going at 0, and that one's going at 15, and just average those three numbers together. That's not the way to do it. We want to say that this total is going to be equal to the total displacement divided by the total time. Now we already have this part. We already have the 85,000. We just need to figure out the total time. So just like before, we are figuring out all the displacements. Let's figure out all the times. So the time that goes by for A, the time that goes by for B, and the time that goes by for C we already have, right? So let me just highlight this. We got these ones now we're going to add together and then put in the bottom there. Okay, so information for A was went 58,000 meters, 20 meters per second. So again, we're going to have to get out our kind of definition here. But we want to solve for delta t. This is a little bit tricky. So really it's kind of a two-step process. We could say I'm going to multiply both sides by delta t. And then I would get, I'm going to erase this in a minute, so I'll just write over v times delta t equals delta x. But now I want to solve for delta t, so I would divide both sides by v. So I'll just cancel that out. So this is how we get it. Delta t is equal to the displacement divided by the velocity. Okay, so we're going to say here, this is going to be equal to the displacement in interval A divided by that velocity during interval A. Okay, so our displacement was 58,000 and our velocity during that period of time was 20 meters per second. 58,000 divided by 20 I think is 2,900. Now our units for this is time is going to be in seconds. Okay, how about for segment B? It says waits for 5 minutes. So 5 minutes is pretty straightforward there. That one we'd already multiplied 5 times 60, 300 seconds. And for this last one it was, I'm just trying to get rid of this. So we have this answer here, and that answer. Those are the ones we're going to add together. So our total time is going to be 2,900 plus 300 plus 1,800. And that answer is, using my calculator here, I think 5,000. So I'm going to put my answer here, 5,000. Okay, so just to kind of show that, this total is going to be equal to the time for A plus the time for B plus the time for C, and that was equal to 5,000 seconds, and we put that over there. Okay, almost done now. Our velocity is going to be 85,000 divided by 5,000, which turns into 17 meters per second. Let's see if that makes sense looking at our thing here. So this slope here was steeper, it was 20. This slope was 0 for some amount of time, and this slope was 15. So it kind of makes sense that our slope is 20, because it was going 20 for the 20 meters per second for the longest period of time, 2,900 seconds, compared to the other ones. Okay, so there's our two answers. 17 meters, maybe I'll put it over here, 17 meters per second. And the total displacement we had was 85,000 meters. Alright, I hope that helped. I think I'll do a separate video for each of these questions, because otherwise it would get too long. Bye.